Do you know sound AI can detect special events? And do you know Universal Studios 30 years ago, there's a movie called Sneakers. They already used speaker verification as biometric authentication. So welcome to our new episode, Edge AI series show. So today we have Cochl team on our show demonstrating their unique technology for Edge AI. But this time we're not talking about computer vision. We're talking about a new technology that is how audio and what sound detects special events like guns, engine acceleration, glass, help industries across manufacturing to smart city to foster their digital transformation. So Cochl is a team aims at a mission where AI can understand all sounds like humans do. I invited Suyong from Cochl team to demonstrating their technologies. So hi Suyong, welcome to our show.
Hi, Elaine, and thanks for having me. My name is Suyang. I'm a business development manager at Cochl, and I'm excited to deliver this session in front of the seed developers community. So, we came across the seed products a few years back when we were searching for a customizable home speaker for deploying our software. And as you know, since the commercial home speakers such as Google Home or Alexa don't provide easy customization for third-party AI software, reSpeaker was really useful for testing and running our own software. So since then, we've been a big fan of Seed Studios because it has such a comprehensive range of products and microphone.
Yeah, thank you. I'm super glad to hear you are using our Red speaker and also our other edge devices like Raspberry Pi and also the NVIDIA Jetson powered reComputer to put into your audio technology into the real devices. I'm super too happy to hear that.
So today we'll be looking into machine listening technology and its applications on the edge. What is machine listening, its use cases and applications on the edge devices, how we're addressing the real life challenges. Later in the demo, I will show you the easiest and fastest way to begin your machine listening journey with NVIDIA Jetson series, how to start from zero and build your first machine listening application with a few lines of code. All right, let's get into it. So before we jump into the basics of machine listening, I'd like to start with a short introduction of our company and our missions. So Cochl is a deep tech company based out of Silicon Valley and Seoul, founded by researchers in audio and machine learning. And we're driven by a mission to pioneer our AI-based sound analytics technology to accelerate innovation across different industries. So on the top right, you can see one of our main services called sound event detection. I believe many of you are already familiar with not sound, computer vision technology that's used for facial recognition or object detection. So while object detection in computer vision enables computers to see things through a camera, sound event detection enables computers to hear things through microphones. It can recognize sound events like gunshot, glass shattering, and help you make the right decisions at the right time. So aside from this, other technologies we're developing in-house include music fingerprinting, machine failure detection, speaker identification, and underwater noise analysis. What exactly is machine listening? So machine listening, also known as audio analytics or sound recognition, is a rapidly growing field that uses artificial intelligence and signal processing to analyze and understand audio data. While speech recognition is limited to understanding the content of a human speech, machine listening is a broader term that aims for automated analysis and understanding of sounds from music, animals, vehicles, machines, urban noise, and so on. By leveraging machine listening, you can extract valuable insights and information from audio data, making it a powerful tool for various industries. And within this broad field of machine listening, there are a few subfields such as sound recognition, which you are all familiar with, and scene classification that aims to classify the environment where an audio clip was recorded. Sound event detection, as we touched on briefly, is about identifying specific sound events such as the sound of a car horn or a dog barking. And lastly, music information or MIR deals with music to extract useful information such as pitch, tempo, rhythm, and melody. And here I wanted to talk some practicality. Why would you choose machine listening over other AI technology or sensors? So first of all, the cost efficiency. Compared to other recognition methods like computer vision, running machine listening consumes much less computing power and resources. And since it's very lightweight, it can run on edge processing on the small computers like Raspberry Pi. And the next thing is the coverage. While it's expensive to keep a camera system that can cover all directions without any blind spots, a single microphone can cover 360 degrees with no blind spots. And when it's installed outdoors, it can recognize sounds as far as a few hundred meters away. And finally, there's an issue that many people are sensitive about when we talk about AI, which is privacy. So many AI solutions have to be always connected to the cloud, so people find it intrusive to have big cameras around them always watching them. So microphones, on the other hand, can be installed to places that are less intrusive and can be processed 100% on edge, so it doesn't have to be sending any audio data to the cloud.
That is great, cost efficient, have a larger coverage, and also ensures the privacy at the edge. So I want to know what industries are you looking into and how do you help your customer deploy the application?
Yeah, so that's a great question. I'll share you what are the real unique challenges that machine listening helps to solve most efficiently. So I wanted to share use cases in four industries: smart cities, manufacturing, defense, and smart homes. So as you can see, we have a lot of partners across all different industries. So the most straightforward use cases are for smart cities. Sounds like gunshot or car crash indicate that a potentially dangerous situation has occurred, such as a shooting incident or street crime. So you can deploy edge devices with sound detection capabilities throughout the city or to the areas with high crime rate, just for instance. And being able to detect these incidents real time can enable faster response to emergencies, which is critical for the police or law enforcement. So we have been partnering with leading IP camera manufacturers and service providers, so their customers can easily add our solution to their devices as a plugin.
The integration parts in the middle, I'm very surprising to find you also work with Dogu, a Korean company focusing on the robots. Yeah, actually, we just featured a case study blog. Talk about how Dogu developed both indoor and outdoor robots using reSpeaker and also different NVIDIA Jetson boards. Yeah, so they have integrated many functions into their security robots working both indoor and outdoor, including the fire, smoke, and also other computer vision detection, and also the speech recognition. I'm super glad to see you also work with them.
Yeah, so I was also surprised to see Dogu from Seed Studio website. So yeah, Dogu has been our partner for many years now, and their robots that has Cochl integration inside is multiple of them are already deployed across the public parks in Seoul, and they are looking for any suspicious activities that can potentially do harm for the citizens.
Yeah, that is wonderful.
So yeah, likewise, in smart homes, smart speakers or indoor cameras with sound detection can trigger alerts for users when glass breaking or footsteps are detected. So if you are a developer looking for ideas to enhance your products, I think this could make a fun project. And even in the defense, there are various ways machine listening can be used to enhance situational awareness and provide critical information to the soldiers in the field. So we have been collaborating with national defense projects and defense companies to detect potential threats and analyze the underwater activities by sound. Lastly, in manufacturing, machine listening is being used to detect anomalies and potential failures in the industrial machinery or home appliances. So, by analyzing the sounds produced by machine components such as motors or compressors, factory operators can identify the indicators of malfunction and take proactive measures to prevent breakdowns and improve efficiency. So by this point, you might wonder how we manage to detect different cases of machine failures when all different machines have their own unique sounds and problems. So, so if you are lucky, you know when the failure happens, so it's easy for you to collect the sound samples. However, if you don't know when the machine fails because it happens so randomly, it's not easy for you to provide the failure data. And for these both cases, we can make it possible to detect the machine failure. For the first case, when you have the even a small number of audio samples, we can recognize the failure using a pre-trained model. And for the latter, when you're not able to collect the failure data, the system will learn what's the usual or what's the normal pattern and automatically mark anomalies if it detects any abnormal sounds outside of this normal pattern happens. So, what does it take to build machine listening applications? Say, if you were to develop a machine listening algorithm to deploy to edge devices from scratch, what are the common challenges you are likely to encounter as opposed to leveraging a reliable machine listening solution? The first thing you want to consider is the time. Building machine listening requires a dedicated research team knowledgeable in handling audio data, which is very different from handling text or image data. And if you were to search for sound detection solutions, you will notice that most solutions are built to be used with a limited type of device or microphones. So it's really challenging to build a device agnostic solution that can work with any type of devices. Then there is the most important element that can decide whether your users will come to love you or hate you, the performance. So even the most popular home devices like Alexa or Apple that have the sound detection features, they are known for high false alarms. Yeah, so how can we streamline this entire process of building an end-to-end machine listening solution from data collection all the way to deployment? By leveraging our ready-to-use API and SDK, developers can easily deploy machine listening to the edge devices such as IP cameras, smart speakers, robots, or mobile applications. So enterprises and individual developers can simplify development of industry-specific and application-specific turnkey solutions and efficiently analyze the statistics and get notifications through dashboard and mobile app. So you can choose wherever you want to deploy your machine listening app, be it on the cloud or on the edge devices. running machine listening on the edge doesn't require large computing power, and you can use small computers like the reComputer or NVIDIA Jetson.
Cochl support a lot of the different platform across the cloud to the edge devices. And especially for the edge devices, you support a lot different architecture and support Intel, ARM, and also the Core and Raspberry Pi, and also the NVIDIA Jetson, which means like customers can select a lot different products that as seed that can leverage Cochl's platform. Yeah. So I want to know, like, for these different devices, are they using the same SDK provided by Cochl?
Yeah, you can use the same SDK for all different devices from Raspberry Pi and NVIDIA Jetson. And since our solution doesn't require huge computing power or resources, you can use the small computers to run the sound detection features. Yeah.
Jetson Nano to the latest Jetson Orin. So we have a full series of the reComputer, but however, their AI performance range the huge difference. So I want to know, how do you recommend people to choose the right hardware according to the different scenarios?
Yeah, so that's a great question. We are using the Jetson Nano for sound event detection. And however, this Jetson Nano might not be enough for handling to be running with other applications. So for other heavier models that require higher computing power, such as speaker identification or machine anomaly detection, we recommend to use Jetson AGX Xavier or higher Jetson models.
That's great. Thank you. So I've learned about the image labeling and also the image detection from the computer vision applications. So I want to learn more about like how the Cochl's SDK include the feature, especially working for the audio detection.
Sure. The developing a machine listening application is very different from developing other computer vision or facial recognition features. So, although you can use the full features with a few lines of code, what's behind this is we have a proprietary data set that contains like millions of unique audio clips and tools for automating labeling, data augmentation, and quality change, downsizing, etc. So these are all built in-house by Cochl research team. So it's really a platform that helps developers implement fully working, high-quality machine listening in minutes of time.
Yeah, yes, that's great. So it included a lot of features just running with a few lines of the code. So what about, let's directly jump into a demo, like how you use the Cochl for executing the sound detection.
Yeah, let's go to a demo and just see how easy it is to get started with machine listening on the ads. So here I have my reComputer ready with a USB microphone connected. And this is what we will do. First, we will create a project at Cochl dashboard. Then we will download the Cochl.Sense SDK. After you are done with the authentication part, you are ready to run the sound detection app. First, open a web browser from your Jetson. In order to create a new project, sign up for a free Cochl account at Cochl dashboard. Go to the dashboard and sign in to your account. After you sign in, click the Add New Project button. Name your project, select Add SDK from the product type, and select text to add target sounds you want to detect. Then click on the project you just made and click Cochl.Sense SDK to visit the external link to download the SDK file at Cochl Docs. On the Cochl Docs page, click on the resources on the left. Scroll down to find the download link for C++ SDK and Python SDK. In this tutorial, we are downloading the AArch64 SDK because we are using the Jetson series. Now let's go download the source code for the sample app. Open a new tab, go to GitHub Cochl.Sense SDK tutorial page, and download the source code. Extract what you just downloaded, and then move the Sense folder to Tutorials folder. This is what Sense SDK CPP Tutorials main folder looks like. Okay, now we have to authenticate our sample app. Go to the example folder, find the Sense Stream CC file, and open it with any text editor. To find the project key, go back to the browser, open the project page, navigate to the settings page, and copy the project key. Go to the Sense Stream CC file you opened with the text editor just now. Paste the project key that you just copied to replace the line where it says your project key, and save the file. And we're ready to go. Let's go ahead and run our first sound detection app. Open the terminal from your Jetson and run the commands to install dependencies. Then, go to the source code folder and build your application with the commands. Run the application and try making the sounds yourself. Try whistling or clapping, or play the sounds from other sources like YouTube. You can see the sound detection results in real time. Make sure the microphone is connected to the reComputer before running the application. To stop the application, press Ctrl+C. If you want to view your detection results from the web, go to your dashboard and click the Analytics tab and set the time range next to the filter button. So in this first demo, we built from scratch a sound detection system that runs on the reComputer powered by NVIDIA Jetson Nano using Cochl.Sense SDK. So Cochl.Sense SDK is a machine listening development platform for deploying deep learning applications on edge devices such as NVIDIA Jetson models. So basically what you are going to need is an edge device and a microphone. So for full tutorial, please refer to the SEED wiki page. And if you don't have any edge devices with you right now, that's okay. You can try the API version or interactive web demo, which can be found on Cochl website.
Besides, the sound detection for the special events. So do you also support the voice detection?
Yeah, that's right. So dealing with voice data is also a major part of our technology. So I'm going to show you running speaker verification on Jetson AGX Xavier. Yeah, although we haven't made this technology commercially available at the moment, I thought it would be fun to show you another example of machine listening. So I prepared this speaker verification for this demo. So we are all pretty familiar to using fingerprint recognition or facial recognition every day when we unlock the phones or laptops. With regards to using voice as an authentication method, there's an old comedy movie made by Universal Studio 30 years ago called Sneakers. And it has a scene where fictional speaker verification was used as a form of biometric authentication. So in this movie, one of the main characters used the voice to unlock the entrance system. So how it goes is like he reads a system on the screen and the system verifies the speaker's identity and opens the gate. Now let's run this demo and see how easy it is to register your voice to the speaker verification system.
Just like the first demo, we are going to need an edge device and a microphone. Here we have a Jetson AGX Xavier with the USB microphone and the Wi-Fi dongle connected to it. And here's what I'll do. First, I'll check if my voice is registered in the database. Then I'm going to register my voice. And after the registration, I'll see if the system can recognize my voice. Although this is not available as an SDK or API like the previous demo, you can try this yourself at Cochl.Labs website. First off, we're going to SSH into the device. Before we use the Python API, let's activate the virtual environment. Now it's ready. I'm going to confirm whether my voice is registered in the system by recording my voice and sending a query for identification. Let's turn on the query. Hello, my name is Suyang. Verify me. It says not verified because I'm not registered yet. If a registered user sends a query,
this is Cochl speaker verification demo on Jetson.
this time it says verified. Now let's register my voice. I can register myself in the system by repeating 5 similar sentences. Let's see the list of currently registered users. It says only Donmoon is registered at this time. I can register myself by recording my voice here. Hello, my name is Suyang. Verify me. Hi, this is Suyang. Verify me. Good morning, my name is Suyang. Verify me. Hello, my name is Suyang. Verify me. Hello, this is Suyang. Verify me. It's done. And we can see that I'm registered. Now the system can recognize my voice. Hi, this is Suyang. Verify me.
Thank you, Suyong. So that is a very cool demo. Yeah, so can you please elaborate more about that, how you achieved that?
Sure, I'll just briefly introduce to the process the speaker verification works. So the process is really simple. You only need to repeat short sentences for 5 times. and it's very accurate verification method with 99.8% accuracy, and you can register up to 40 different individuals, which might not be best for granting access to all employees at a big organization, but it's great for adding an extra layer of security for limited access areas, or to enable smart speakers at home where you can create a voice profile for each family member. And because of its relatively small size, you can run it 100% on the edge and keep your biometric data private. This will also save time and cost of using the cloud. So there are lots of benefits of using speaker verification as a verification method.
Okay, that is great. Yeah, that is great to demos. I think I can expect you will release the speaker verification very soon at Coco. So what are the other plans at Coco platform?
Sure, I'd be happy to share what we have on our roadmap. So we plan to continuously update our supported sounds to our solution, which now includes 34 different sounds. And we also plan to launch an official release of speaker identification and machine anomaly detection within this year. So we are going to gradually expand our solution and add also the speech recognition, so our solution can support really all kinds of sounds, verbal and non-verbal.
Yeah, that is great. So for developers, you can just try the Coco for free, and also you can just follow our wiki for a step-by-step guide to try Coco on the different edge devices. And also, so you can also enjoy the Cochl.Sense SDK license trial by submit interest to Coco. So Coco then will send you a 2 weeks free trial by submitting the Zoom. So where do you have any events attending and we can have a conversation with you or have a live demo to experience Coco's experience?
Sure. If you want to meet our team in person and see how we're innovating the security solutions, you can come see us at ISC West in Las Vegas, which is held later this month. And you can always contact us through the email or the contact form on the website.
Yeah, that's wonderful. We're very excited to co-demo with you at your booth at ISC West, Las Vegas. Yeah, so thank you, Suyong, to share with us this unique technology. I look forward to seeing you again with your more latest updated functions at Coco platform.
Thank you, Elaine and Seed Studio for hosting this webinar. And it has been a pleasure being with you today, and I hope this has been a useful and informative session. Yeah, so I look forward to hearing from everyone again.
Yeah, thank you. Be sure to stay tuned with our updates at ISU West, the demo, and also the wiki page.